Good evening, everyone. In our team, we made a game. In my part, I make the game in Unreal Engine 5. It's a first person shooter game, multiplayer, can drive. Max makes the machine learning learn from the data from my output and to find out which player can what the vehicle they use and what the combat score that they get and to calculate what the player can get in their future combat. SuoHao use our data to make the website to show all the data uh, of the players and the team. Okay, I will show what I did. Before the midterm, I make the environment of the multiplayer and the only vehicle and the basic trooper from the two campus, and they can use the weapon to shoot each other and to get the score. And the player can drive the vehicle. That is what I did before the midterm. After the midterm, I make the variable classes for the tanks and the other vehicles, and the main difficult challenge the challenge is was the data what how to get the result the scored result from the two mode. Because in Unreal Engine the game mode for the player for the trooper, this one is different from the switching from the trooper to vehicles. So that is a kind of in the two different system in the game mode and player controller. So that how to share the data is the very challenge for me. But the most challenge for the recent days is the output from the data. For example, in here, this one, because when we shoot the projectile from a vehicle, it need to calculate what is the owner from the tank. For example, the actor shoot the projectile and hit another vehicle, so that we need to trace this one, the owner, and the hitter, so that as my previous 2 months experience, I just put the data to store the data in the player base. As you can see in here, previously I stored it in here and the tank, but in Unreal Engine the format is not like this. The only thing is to store for each client is in the player controller. So that, as you can see, I put all the data, all the variable in here, and the projectile we cannot store in the blueprint, because in the blueprint we can only calculate the physics. For example, in the collision, only store the data for the server, so that it cannot get the data for the client. So in the C++, I solve it in here to trace what is the where it is to store I stored the data on heat, so for example in here, so that it will solve the problem. I will show you how the combat look like. In here, I use the 4 players and the listening server. I delayed the output data and after the combat, it will generate a new one. In here, as you can see, 4 players, and in the server, if I input the wrong name, will join choose the weapon, main weapon, secondary weapon, drop. The melee weapon, switch it. Switch it. Going into the vehicle. Third person to first person. As you can see, the projectile, if I aim further, is kind of it will show the trace from the barrel to the hit point, so that as you can see, the movement of the projectile is a curve. Yeah, it's one of the challenges in the beginning. And I will show you the other players. First person to second person. Here's a bug, I will fix it later, of the shaking barrier. Get into a tank. Another one, the last one. The 3 letter. The combat. I just simulate what the combat look like, and if in the real match, in the real combat, it will be something more, will be more challenge. Here, if I shoot, oh no. Maybe they have the physical issue or something, so that I shoot another one. Okay, finally. In here, because I need to get the data from the killing number, so that is why we need each of the team to kill at least 1 people. Later on, I need to calculate what the health for each of the projectile and each vehicle. Maybe here have some issue, I think. Oh, they all use up the data. They all. Also can jump, can score. Yeah, definitely the tank need have more health, so that it's hard to make any damage to the tank. So we get the feedback from here. Okay. After this, we have the we get the new output, something like this. As you can see, Q1 uh, Q1 dash it like this, so that the win is for the GDI for the last EE player. Yeah, so this is the damage he, because he make more the maximum output, and he get the minimum. Yeah, something like this, so that the data will give Max to do the machine learning. Then I will give the screen to Max. I will Max here. Oh, Max screen. Okay, Max.
Okay, after the midterm, my job mostly is one is create this daily job Python file. It is used to run all the files except the store data because the store data will be run with the game file, game, game program that it will read the game log files and store it into the database on the we will put the database on the cloud. And all the other jobs will be run on my computer uh, with this file, we will run like this. We will use this code to run the files, and we uh, the the game log files will be stored in the race table, and we will use my program to get the vehicle efficiency and the player vehicle percentiles, these two tables. The score and the vehicle efficiency is to show that if this how do this vehicle or this player compare to other players or other vehicles. 100 is average. It means you are this player or this vehicle is in the average level, and higher larger than 100 means this vehicle is stronger and it do more things than average vehicles. Uh, the race data it is now generated by myself randomly. So after today we will I will use the YaolongLiu's data files and try to test the store data if the store data Python file can work with YaolongLiu's log files. And after the midterm, I also changed the changed the way I communicate with the website. We now store all the data in the database. But before midterm, we try to like communicate with the WebSocket like this, and now we just don't use that. And we will after today. I will also do another thing is to automation. Now if I want to run this file, I need to type some codes in the terminal, but I will make a daily automation program that can run this file once a day in the same each day at the same time, and like I will save the models once a day too. That's all. So
Okay. After the midterm,
I
I
need to switch. I need to switch to your
okay.
screen. Okay. Okay.
Okay. Thank you. After midterm, I updated the portal by making it more interactive and integrating it with our machine learning data. I also added a Firebase authentication to the website. The first thing I added is a search functionality on the homepage, so you can enter either a player name or a vehicle name. So, and it will automatically go to corresponding page. For example, if I enter a tank name, a vehicle name, so it will show the corresponding data. For the player page, I connected the chart to use the machine learning data from our backend instead of more data. Another update is a fire-based authentication. You can see now we can register and log in to the portal. Once user log in, for example, if I okay, when the user log in, oh sorry, when the user log in, they get access to extra data that comes from our backend. For example, the predict win rate and the efficiency scores for every vehicle. So also you can sort the data by these values to compare vehicle performance. So if you log out, the corresponding data will disappear. So at this stage, access control is only implemented to the vehicle page. I'm planning to extend it to the player page as well. Let login user compare two players on the same chart. So they will be able to choose what to compare, such as win rate, vehicle type, or other states. So the biggest challenge I met is the chart scale. The backend prediction results were extremely large, sometimes around 2,000 or even 8,000. But the real win rate are only between 0 and 100. The small numbers were almost flat or invisible. And to fix that, I wrote a formula that takes the minimum and the maximum scores and map all values to range between 0 to 100. This part took several texts to get right. Before the final, I will continue building the comparison feature and finish the access control for player page. Thank you for your watching.
Okay.
Okay.
Thank you.